Hello and welcome. In this session, we will just pick an example. What could be your project work, which is, let's say, database management system design on implementation for a pharmacy. Just one branch, not the whole chain business. So one branch could be the one branch of Shoppers Drug Mart or Guardian and so forth. Um, so this is by no means the whole project. You will have to do, as the requirement says, the business rules. Then you'll have to do the ERD, and of course, you need to identify the entities, their relationship, and then you'll have to do the normalization, and then finally you land on your schemas. That means how many tables you will have, and then you implement and then you insert some data. So your final project requirement is that one document or PDF file containing all the design, that is the business rule, ERD normalization. And then other one is the script file, .sql or txt, containing the scripts to create the tables with the constraints and relationship, and inserting 5 to 10 sample records into the table. So those are the two files submitted. Now, I'm going to just do a brief discussion how a pharmacy schema could look like. Well, when you're dealing with pharmacy, then you're dealing with drugs, or the medicines, and then they have suppliers, and there are category of medicines, and there are customers placing the order or providing the prescription from the doctor, and customers making the payment, and that payment could come from um, insurance provider or the customer's own pocket, depending on the situation. Some drugs may not be covered, and so forth. So this is the information you gather initially interviewing the client, what things to be stored, and then you write down the business rules, and then you tend to identify the entities and their relationships and so forth. So I have here um, a category or type of drugs. That could be one entity. So we have the category ID, category name, like some drugs. I don't know, I'm not a medical person, but it could be like painkiller or uh, cardiac medications or diabetic medications, or some could be what do you call them, injections. It needs to be stored some a special place and so forth. And of course, drug in Canada, we have some, I've seen some RX number. Probably this is related to the Ontario or provincial number that the healthcare system needs to know, go by that code to subsidize a senior citizen and so forth. So we have some sort of ID for the drug identifier as primary key, the drug name, description. And one category can have multiple drugs, but a drug may be falling under only one category or one type. So it's a one-to-many relationship between type and drug. So type is, or category is one, and drug is many. So we bring the primary key of one side to many side as a foreign key, which we discussed. Now, these all depends on your business rules. Okay? And every drug should have a supplier. Once the supplier supplies, then you note who supplied it and how many quantity, and there could be billing for the supplier. We are not probably considering this here, but you can bring that business rule in if you want. So maybe one supplier can supply multiple drugs, but a drug is coming, particular ID drug identifier coming from only one supplier. So again, that makes it one to many relationship. So I put the primary key of one side into the many side as a foreign key. And the quantity of that drug is like, if there are 10, then if someone purchase one, then the quantity is deducted, and then available quantity should be 9. So that's just an example why we use quantity, or the pharmacy should store information like how much you have left of particular drug. So a notification could be generated so the pharmacy knows when to order it next and so forth. That's the reason we should have quantity. It's not the quantity or order quantity, it's the quantity in at hand in the store. Okay, the quantity, how much the customer ordered, that should go into the order, right? Okay. So that's three tables. Now we move on. And again, it depends on your business rule. And based on that, I generated the schema. But your steps should be business rule first, then ERD, then normalization. Then you finally come into these tables. So next is insurance. Now I didn't consider the insurance company name. I'm just putting insurance information, insurance number, insurance address, for perhaps that stores the company name, and the phone number of the insurance supplier. But if you bring the insurance company, then you have Sun Life, Manulife. Um, it's been between customer. It's a many to many relationship. That one customer can have many insurance. Like I got multiple insurance. Um, from different workplaces, and the same insurance company can provide insurance to many customers. So if you bring company, then it becomes many to many. But here, since we are focusing on what are we storing in the pharmacy database only, I made it one to many, that a customer can have many insurance, but it's not dealing with the provider. It's just an insurance number. That number ID is provided to only one customer. So that makes customer one side and insurance many side. But if you bring companies like insurance provider, Manulife, Sun Life, and they're providing insurance to many customer, and a customer can have many insurance provider because they work. They have different employers. I mean, several employers at the same time. Then it becomes many to many. But in this case, it's just insurance number we are keeping in the pharmacy database. So this is many side, customer is one side, okay? And number is given to only one customer. But that depends on your business rule. It's not that you have to follow what I'm discussing here. Next is doctor. Of course, the prescriptions that the pharmacy uses to give the medication to the customer, that has to come from the prescribed medication. It's not over the counter. That has to come from a doctor. So the pharmacy might want to store doctor information as well, doctor ID, first name, last name, phone, fax, and so forth. Okay, and now the order. This order is it could be a prescription that the customer brought, or it could be just over the counter medication. So if there are doctor information prescription, then it's one doctor, and of course one customer can place many order. So order is many side, customer is one side, and in one order there could be only one prescription, I believe. So that's why I have one here. It's just mind mapping information. So you write your business rules. So order will have order number as the primary key, order date, customer number, because one customer can place many orders. So customer is one side and order is many side. That's why customer number comes here as a foreign key. And doctor information also foreign key. Total amount to be paid, that's information should go in order as well. Now payment, it depends. I go to usually one pharmacy, and different times I make different types of payment. Like one order I pay by card, one order it's covered by insurance, one order I pay cash, and so forth. or there could be a mix-up. So, let's say they bill X amount of money, and you say, okay, you're going to pay Y amount out of X by card and X minus Y amount by cash and so forth. So depending on your situation, it could be many to many relationship. But I think I tried to keep it simple in the business rule that one order has one payment type. Okay. Is it card, cash, or so forth? But it depends on business owner, and different situation could arise that a customer is making payment, two types of payment for the same order. Okay, some part e-transfer, some part cash, and so forth. So you decide in your business rule. Okay, now we also need another table order detail. This is per order, one order or one prescription. There could be multiple medication, or in the same order, it could be some prescribed medication from doctor and some over-the-counter medication, and so forth. So there has to be a one-to-many relationship between order and order detail. Order is one side. Within the same order, there could be detail, multiple drugs. Okay, so that's also coming from drug table. And the coded price, different drug could be coded during that particular selling time of that order. It could be sold in different price. So we need a coded price of the drug, and in the drug you can also store the price, the current price. I leave it up to you on your business rule. So we have the order detail having coded price, the drug number as a coming here as a foreign key, and the order number. One order can have multiple drugs, so multiple rows will be related to one order. Okay, so that's why we need an order detail, and that's one-to-many relationship between order and the order details. So order number comes here as foreign key, and so is drug number foreign key, and it composite primary key. Okay, the other thing I have is zip. Now this is once you normalize to third normal form in order to remove transitive dependency. Now go through the recording of third normal form. You will understand. Oh, my phone is ringing. Okay. Um, so sorry about that. So we were talking the third normal form, zip code. Customer, usually if there is a pharmacy and there could be people around living around the same zip code or around the pharmacy, they could be going to that pharmacy. Like, those are potential customers for the pharmacy located in the zip code. So in one zip code, there could be many customers living, right? So zip code is one side and customer is many side. So zip code goes to the customer table as a foreign key. So this is to remove transitive dependency. We need to take it to third normal form. That's why I have this zip code as a separate table. And it could be similar if there are multiple doctors living in the same zip code and the patients in the same area. Like usually you have a center building where you have all the doctors, different types of services, medical services being provided. There is a pharmacy inside, and so forth. So maybe the customers around that area going into that one building where you have all different kinds of services, different types of doctors are there. So then in one zip code there could be multiple doctors offices residing, right? So that's for third normal form. So again, zip code is one side and the customers and doctors would be many side. So we don't have to repeat these city and province information in customers table many times if there are many customers living in same zip code. So that's the reason we separate. And then one zip code can determine city and province, and that will appear only once. That was the purpose of removing transitive dependency for third normal form. Okay, so this is, in short, I have I have the schema, pharmacy schema in place. Again, it depends on your business rules, and then you design your ERD, then normalize, and then finally you come to this stage. What tables you have, what are the columns, and their relationship, and then finally you implement, right, with Oracle or so forth. Okay, thank you very much.